All right, ladies and gentlemen, so welcome to our heart dissection. So I actually have two hearts here. You will not be dissecting two hearts, but I wanted to show you both. So this one here is a pig heart, and pig hearts are roughly the same size as human hearts, but this one here is a sheep heart, and the sheep heart is the one that you will be dissecting. But I wanted you to see the difference in size. Sheep hearts are quite a bit smaller than pig hearts, and therefore they are smaller than human hearts. We can also see that while they roughly have the same shape, there are definitely differences. But what we're going to start out with is the external features that you're going to need to identify on the heart. Okay, so just looking at your lab sheets, we have a few different things going on, but first we need to orient ourselves. So looking at it right now, I have the anterior surface of the heart facing out. The apex is the pointed part on the inferior surface, and then the base is going to be this wide open portion that's going to have a lot of your great vessels. Okay, on both of them we have a wide base on the superior aspect. Okay, so with that understanding, we're going to need to look at where our chambers of the heart are. So the ventricles are closer to the apex on the inferior aspect, while the atria are closer to the base at the superior aspect. Okay, now as always, you are looking at these as if they are your patient. So this is the patient's right, and this is the patient's left. All right, and so that means that our right atrium should be right around here. Our left atrium will be right around here. Our left ventricle will be over here, and our right ventricle will be over here. Same thing on the sheep heart. So we're going to have a right atrium, a right ventricle, a left ventricle, and a left atrium. Okay, now a trick for finding your atria is to look for the auricles. So remember, auricle, like auricular region, is like a floppy ear-like thing. So let's look at our sheep heart first, and we have this kind of floppy thing right here. So this is our right auricle, and our right auricle is going to be on top of our right atrium because they are continuous with one another. And then we have our left auricle over here. Okay, same thing on the pig heart. So we have our left auricle here, and our right auricle is here. Okay, so we know that in both cases the atria are attached to that particular area, and then of course the ventricles will be below that. All right, so with that understanding, we'll go ahead and move on, and let's see what's on your lab sheets. So let's go with our sulcuses, or sulci. So just like in the brain, a sulcus is kind of the space. Okay, so remember, our gyri were the wrinkles, the sulcus was the space between. So the space here where our blood vessels would run, our coronary vessels, this is the anterior interventricular sulcus. Now that makes a lot of sense. So inter is between, interventricular, in between the ventricles. So our left and right ventricles, this is kind of in between them, and it's a sulcus. It allows the blood vessels to run in them. Okay, so we would have a number of blood vessels here. We don't really need to know them for the dissected heart, merely because, well, they're not here. So on a model, though, you would need to know the anterior interventricular artery and the anterior interventricular vein would be running around in this area. Okay, but if you're looking at a dissected specimen, this would just be the sulcus. Okay. Similarly, on the sheep heart, we can see running right here, we have our anterior interventricular sulcus. Now, if that's the anterior interventricular sulcus, when we turn it over, we have a posterior interventricular sulcus on either side. Okay. Similarly, it would hold blood vessels. okay? Now, our last sulcus is the coronary sulcus. So the coronary sulcus actually runs in between what would be the atria and the ventricles. So it kind of goes around. It's difficult to see at certain points, but you can see here, and then it's very nice here on the back. So you have the sulcus there. And on the pig heart, it's on the back is difficult, but you can see it very nicely right there, okay? So that would be your coronary sulcus, okay? So those are all our sulci. So let's see, what do we want to do next? So let's look at the great vessels. So the great vessels here are structures that are coming out or into the heart. And to be able to tell which one's which, you really have to have already oriented yourself. Because they cut them so short, it's difficult to identify them otherwise. So in a testing situation, I would always orient myself first, make sure I know what I'm looking at before I try to identify the different vessels, okay? But we have this vessel here. I can stick my probe into it. And it is coming off of this right portion of the heart. So this is your pulmonary trunk. So the pulmonary trunk, of course, would branch into your right and left coronary arteries, but it has been cut off before it can do that. Now, just posterior to that, we have another large vessel. I can stick my probe in here. And this is your aorta. Now, specifically, this is the ascending aorta, because the next part would be the aortic arch, which has been cut off. So this is the ascending aorta right here, okay? Now, there's another vessel right here. You can kind of open it up and go inside here. And that is going to be your superior vena cava, okay? And that is about it for this heart. Its other vessels have kind of been cut too short, so they are not visible. But let's just go ahead and finish up by looking at those same great vessels on our sheep heart. So as we're looking, we have the most anterior vessel that is coming off the right heart, and so that makes this our pulmonary trunk. Then just posterior to that, we have another vessel here, which is going to be your ascending aorta. Again, it's been cut off before we can get to the aortic arch. And this one has been cut so low that we've actually lost the vena cava. It is opening up directly into the right atrium, okay? So for our external features, that is all that is on our lab sheets. We will start our dissection in just a moment. All right, guys, so now we're going to look at how to actually do the dissection of the sheep heart, which is the one you should be dissecting for yourself. So just as we have mentioned before, make sure the blade is pointed away from you, okay? You're always cutting away from yourself. So with the sheep heart, there's several different ways that you can do the dissection, but what we're going to do is we're going to go ahead and find the apex of the heart and go ahead and put your scalpel in like that, just so you're about to the end of the blade, and then you're going to slowly cut up through the left side of your heart. You might have to do a sawing motion to make it work, or you might be able to just go straight through depending on the sharpness of your blade and the ease of your heart, okay? So I'm going to just go ahead and put this down for a second so that you can see what I did. So I did a cut all the way across. Now this is not going to be enough. We're going to have to cut the other way too, and then we'll probably have to deepen these cuts. So I'm going to go back in at the apex, and now I'm going to cut the other way. Now you'll notice I'm cutting away from myself. At no point is the blade moving towards my gloved hand, but my gloved hand is anchoring the heart in place so that the heart doesn't move anywhere, okay? And so that is enough on both sides. Now, when we start to pull apart though, we see it's still attached. So what we need to do now, very carefully, pulling it open, and I can't show you and do this carefully myself, so I'm going to have to look down myself here and just cut down any tissue that is holding it back. Okay, so I'm going to go ahead and open it up here, and you can see how this looks. Okay, so we've just cut through. This is, of course, a coronal or frontal cut of the sheep heart. All right, guys, so now that we're inside of the heart, we're going to look at a couple more things before I do any more cutting. And essentially, we need to make sure we're oriented. Now, we had already picked out which side was the anterior, which side was the posterior, which side was left, and which side is right. But once we're inside the heart, we can confirm that we're correct on all those things. So you can see that there is a small chamber here, and then there's another chamber here, but it has much thicker walls. You see the thick walls here and the relatively thin wall on this side. So both of these are ventricles, but one ventricle has a thicker wall than the other. Any ideas which one's which? Good. So the thinner walled ventricle is going to be the right ventricle, because the right ventricle only has to pump into the pulmonary circuit, whereas the left ventricle has to pump into the systemic circuit. So it has to be able to pump blood all the way to your toes and all the way up to your brain. But the right ventricle only has to pump to your lungs, which isn't very far. So because of that, the muscle is much thinner on this side than it is on this side. Okay, so if you were in doubt when you were looking at the external surfaces, this is the quick and easy way to make sure that you are correct. Okay, now I do want to just make sure we're oriented here. So the apex of the heart is still up here, and the base of the heart is down here. Now, the reason why I haven't completed this cut is I want you guys to see these structures here that have been cut on either side. And I'm trying to get a good angle here. So you can see all of these strings here. There's all these string looking things happening. So these are going to be your chordae tendineae. So chordae tendineae I can think of as being cords, right? So it's these strings that are attaching this kind of fleshy tissue here to this muscular tissue here, and you can also see it, oops, if I can hold it, attaching to this muscular tissue here. So this little muscular tissue that the chordae tendineae is attaching to is your papillary muscle. Okay, remember your papillary muscle is going to contract, and when it does so, it pulls up on the chordae tendineae, and that deals with this fleshy tissue here. So what would this fleshy tissue be? A valve, right? But this valve is associated with, we can see here, the thicker walled left ventricle. So this is going to be your mitral valve, okay? All right, so I'm going to go ahead and pause the video for a second so I can cut this a little bit better, and then we'll continue. All right, guys, so we are now looking at the fully bisected heart. This is still a coronal cut. I've just opened it up a little bit here so that it sits open by itself. Of course, when I did that, it broke our mitral valve, which is why I didn't do it earlier. But now that we're nicely laid out, let's make sure we're well oriented. So up in here, this is going to be our right atrium. Now our right atrium would also be over in this area. Remember, we've just flipped the heart open, okay? So right atrium on either side here. This makes this our right ventricle. And then we have our left ventricle on either side here, and our left atrium on either side here, okay? And we can also see that we have a little bit, it's probably better on this side, we have our chordae tendineae again on this side, a little papillary muscle there, and so that makes this valve that is going from the right atrium to the right ventricle, this valve has got to be your tricuspid valve. Okay, so then we need to go from the right ventricle, and let's see which side has the opening. Looks like this side up here has the opening. So if I kind of tilt this, you can see that this goes down deeper this way. Okay, so the septum here is covering it up, but when you pull it back, you can see it goes down pretty deep. So when we put our probe through, we're going to see that, well, you can see it's poking right there. And if I can get it to angle just right, I'm not sure I'm going to be able to get it to angle right. There we go. Okay, so we went from the right ventricle out through this vessel, confirming that we were right before, or I should say we're correct before, since we are talking about right-handed things here. We were correct before that this is the pulmonary trunk, okay? Because the pulmonary trunk, of course, is coming off of the right ventricle, okay? Because of the sharp angle here, it is difficult to impossible to see the pulmonary valve, but we can assume that it is up in this direction, okay? So then blood is going to come back into our left atrium from our pulmonary circuit. And let's see, oh, there we go. There's our hole. So this here is going to be a pulmonary vein that is depositing blood from the pulmonary circuit back into our left atrium, okay? Now, within this left atrium, again, we can see the mitral valve we talked about before. We still have our chordae tendineae. We have our papillary muscles. We can still see within this left ventricle that we have a very thick wall on this side. This is helping us identify it as left. We also see the interventricular septum here. And this interventricular septum is essentially the fleshy dividing line between the left and right ventricles, okay? Now, similarly, we would go from the left ventricle into the aorta. So let's see if we follow this, we end up coming out through what we had identified as the aorta previously. So that makes this hole here the aorta. And that means that some of this tissue here is probably the aortic valve, okay? Some of this stuff here is probably aortic valve, all right? All right, guys, so we just need to go back to two other terms that we didn't mention previously. So the first one is going to be our trabeculae carnae. So I'm going to go a little further down here, and you see here on the ventricular tissue that these are the papillary muscles up here, but there's all of this rough tissue around it. You can also see it up here. So there's rough tissue in here. So that is our trabeculae carnae. So trabeculae carnae, just it looks like rough tissue within the ventricles, okay? Now, the last term that we haven't mentioned is our pectinate muscles. So I'm going to go ahead and close up our sheep heart here. And remember we had our auricles here, and we said the auricles were adjacent to each of the atria. Well, when we open it up, we actually see inside of the auricles here. And you can see that there's kind of a rough tissue inside of the auricles, and that is our pectinate muscles, okay? So the pectinate muscles is the rough tissue inside of the auricles. You can see that pretty well on this one because we've cut it open quite a bit. And you can see it just a little bit on this one. All right, so those are all of the terms that we needed to know for the internal portion of the sheep heart dissection. What we're going to go ahead and do right now is I'm going to show you those same structures on the pig heart. All right, guys, so for our pig heart, we looked at before the external features. So I still have the anterior aspect on top. I'm going to go ahead, I've already done the cut, and I'm going to flip it open. Now, again, this is a frontal or coronal cut. It's just instead of me flipping it superiorly, I flipped it laterally. So now we are seeing the two halves of the heart. This is our posterior half, and this is our anterior half. Now, just like we saw before, we have a thicker wall here and a thinner wall. Now, you'll see that this is not as thin as our sheep heart was, but it is definitely still significantly smaller than this one here. So this is still our right side of the heart, and this is our left side of the heart. As I mentioned previously, this is much closer to the size of a human heart. And there's a few very interesting features that we can see here that we couldn't really see very well on the sheep heart. First of all, this is our auricle, okay? So this is the auricle we looked at before. And this auricle here has been cut open. And let me see if I can move it a little bit with my fingers here to kind of show you. It's not showing super well. Let me go ahead and do it with the piece that's cut off. So you can see that there is kind of rough areas inside of there. So this is tissue that could be opened up in the case of needing more space to hold blood. Okay, so that is the auricle there. Also, you'll notice that there's really not a lot of space in our right heart. And that is because this right heart has a blood clot. So there is a significant blood clot on the right side of the heart. I don't know what happened to this pig to cause that to happen, but you can see that most of the space of the right heart has been taken up by this blood clot. However, you can notice here, if we kind of move things aside, we still have a space here where you can see the difference between the right atrium and the right ventricle, okay? So this here is going to be your papillary muscle, and it is attaching, let me go ahead, hold on one second. I'm going to try to pull some of this out. Okay, that's a little bit better. Okay, so you can see a little bit better now. We have some of our tricuspid valve, and I'm going to pull up on this. So here's our tricuspid valve right here, okay? And so the tricuspid valve, of course, is the opening between the atrium and the ventricle down below, okay? And let's see, can we find, I'm not sure we're going to be able to on this heart. Oh, there it is. Okay. And our probe is going through and it is coming out here, which is, of course, when we close it back up, what we identified previously as our pulmonary trunk, okay, coming out of the right ventricle. Now, what we can see really nicely in here, and this is one of the main reasons I wanted to show you guys this, is we have our aorta, okay? And the aorta has our aortic valve here. You can see a little bit of the aortic valve on both sides, okay? And so you can see this much clearer on the pig heart than you could on the sheep heart. You can also see up here on our left atrium, this is the pectinate muscles that we were mentioning before and we were having a hard time seeing. So these are the pectinate muscles here that are within our auricular tissue. This is our auricle, okay? So these are the pectinate muscles, this rough tissue right here. We also can see very nicely here, this is our tricuspid valve. These are our chordae tendineae, and we have our papillary muscles here. We can't see the trabeculae carneae very well on this one. We'd have to cut back some of these papillary muscles. They're just a little bit too much in our way. But overall, for this pig heart, we're getting a better sense of the aorta, the aortic valve, and our pectinate muscles. Okay, so as I said, you guys will not be dissecting a pig heart, you will be dissecting a sheep heart. However, I did want to point out some of those features because it is a little closer to human size and a bit easier.